you guys are watching the recording. You had to fast forward through lots of classes. My practical math went over, my algebra 1B went over, so this is the third class on the same recording. So anyway, but today I also realized I forgot to post the announcement today. Sorry about that. But the good news is that you sort of have a break if you've already finished up your Unit 2 test Part 1, because we didn't have the Part 2 this time. And so you don't have to start Unit 3 till tomorrow, but you can certainly start it today, since we're going to go over it today if you like. So anyway, we'll be sort of ahead. But we'll cover 3.01 and 3.02 today, and that'll get you ahead to Wednesday. And then Wednesday we'll finish up the rest, or I don't know, maybe we'll just keep going, and then Wednesday could be short. We'll see how it goes. All right. So how's everything going out there for you guys? How'd the Unit 2 test go? Good. Yes, I know what you meant there, Amelia. Yes, you'd have a capital G on the first one if that's what you meant. Okay, good, good. I'm glad to hear that things went well, and I hope that that continues here in Unit 3. Unit 3 is one of my favorites. Well, actually, no, I'm thinking of Semester 1. Never mind. But Unit 4, Semester 2 is one of my favorites, so we'll get into circles. It's kind of fun. It's actually, for students, probably not one of your favorites. So I don't mean to be cruel, but once you figure it out, it's fun. It's just getting to that point that's always challenging, but it's fun because it's sort of like a big puzzle, and every problem's different, which is one reason that you guys will not probably care for it too much to begin with. But once you start to piece everything together, then it does get fun. Okay, so let me change polling real quick because I always forget to do that. All right, 3.01, let's get going. Okay, so these two questions you probably won't know right away, okay? But they are intuitive, so give them a try. Oh, looks like some of you have already gotten into 3.01. Awesome, good. Question 1 says, which of the following scale factors would produce a contraction under a dilation of the original image? So first thing, if you haven't gotten into 3.01 at all yet, there's a lot of vocabulary there. We have talked a little bit about scale factors, though. Do you guys remember? Raise your hand if you remember scale factors from Semester 1. It's been a while. Okay, Mason. All right, well, not too many. Scale factors are a number that you multiply by to make something larger or make something smaller. So think of it like you've probably encountered this in an algebra class maybe before with a picture. A lot of times it's like a common word problem where they'll say, okay, take this picture, like let's say it's a 4x6 picture, and you want to, it's a really, really good picture, and you want to put it on your wall or give it as a gift. So you want to make it into an 8x10. So that would be an example of where you would need a scale factor to figure out what you'd multiply each side by to make it from the 4x6 that it is now into an 8x10. So scale factor is just a number that you're going to multiply by to make it something larger. Or let's say you had an 8x10 and you didn't have a frame for the 8x10. You wanted to make it smaller. You needed a 4x6. Well, you could also take a scale factor and multiply it to make it smaller. Now those scale factors are going to be different. To make it larger, let's say for ease of use, let's say you're trying to make it larger, let's say you found out you needed to double it. Well, then you'd multiply each side by 2. But if you were starting from the smaller, or from the larger image, and you needed to make it smaller, you would do 1/2, or the inverse, or the reciprocal of the number that you used to make it larger. Okay? So, the summary of these two questions that you need to know for now anyway, if you're going to do a contraction, contraction means smaller. So if you're starting from something larger, you're wanting to make it smaller, we call that a contraction. And the number, the scale factor that you would use needs to be between 0 and 1. So all you have to do, if you know those two vocabulary words for question 1, you can answer this question by looking at your answer choices, figuring out which number is between 0 and 1. You see Amelia and Anthony and Mason already have that. And Nathaniel and Wada and Callie, you guys have that. Yeah, there you go. Some more is starting to get filled in there. You guys are seeing it. Okay, so a scale factor is one of these numbers here is the scale factor. They're asking which one of those numbers would produce a contraction. So in other words, which one of these numbers, if you multiplied, is going to make the number smaller. So think of it this way. Let's say you don't even have a 2D image. Let's just think of a number. Let's say we had the number 10. If we take 10 and we multiply by 4.5, what do you get? 45, right? And that's larger. So you went from 10 to a bigger number. Okay, and that's not a contraction. Contraction means you're going smaller. So you're wanting to make it smaller. Okay, but let's say we take that same number 10 and we multiply by 0.5. Now what are you going to get? A smaller number. Yes, Amelia, what is that smaller number? 5, yes. So we went from 10 to 5, so we got smaller. And that is a contraction. So if you chose D, that is correct. Give yourself a round of applause. Yes, I love how Atiro wrote. His last name now is Mr. Late. That's okay. That's okay, Atiro. We just kind of are getting started slowly here today anyway, so you haven't missed too much. We just talked about number 1, and that's actually it. Yes, we'll blame it on your homeroom teacher, not on you. All right, question 2 now. Okay, so you know some vocabulary from question 1. Let's apply that to question 2. So scale factor. Okay, we want to know which of the following scale factors, so A through D are your possible scale factors, which one of those is going to produce an expansion? Take a guess. What do you guys think expansion means? Like if you have a picture and you expand it, what's going to happen to that picture? Right, good. It's going to get bigger or expand. Very good. Enlarge. I like how that word, Kelly. Yes, enlarge. Okay, so if you're not sure, if you forget this rule, I'll tell you the rule. If you're going to enlarge it, your scale factor just needs to be something bigger than 1. So if you take a look at the answers here, now they're in fractions, so you have to put on your thinking cap. You got to think, okay, what is 2/3? Is that larger than 1 or smaller than 1? What about 1/2? What about 3/2? What about 3/4? What's the key when you're looking at a fraction? How are you going to know if it's larger than 1? Some of you guys have it already. Awesome. What was the key that told you the fraction you were looking for? Good. The numerator is larger than the denominator. Absolutely right, Kelly. So C is correct because the 3, the numerator, is larger than the 2, which is the denominator. Very good. So this is the only one that's larger than 1. That's your answer choice. That's going to expand. Okay. Very good. Very good. All right, let me grab this link for you. Sorry, I don't have the PowerPoint open yet. Let me get that open. So I can grab the link for you. And this is just an extra resource. It's not a video. It's just a website that has more information on transformations and dilations. So we've talked so far in question 1 and 2 there about scale factor and contraction and expansion. That is part of contraction or an expansion can be summed up as a dilation. So if you hear the word dilation, that's either shrinking an image or making it larger. Okay? So question 5 says, what must be true about the image of triangle JKL under a dilation with a scale factor of 2/3 and a center of dilation at point C? Okay, now we haven't talked about the center part yet, but take a guess with the scale factor of 2/3. Just take that part alone and let's concentrate, narrow down on that. What would happen to this triangle if the scale factor is 2/3? What would happen? What is 2/3? Is it between 0 and 1, or is it larger than 1? Those are the two categories that we've talked about so far. In case I have, whoa, debate going on. Either going to contract or get smaller, or say larger. Let's see, there's 3 so far that say smaller, 2 that say larger. Let me take it off of follow if you guys want to go back a screen. What is 2/3 as a decimal? Can you guys tell me that? What is 2/3 if I convert that to a decimal? What is that? Okay, good, Nathaniel. Yeah, very good, Mason. So it's actually 0.6 repeating. Okay, and that means it's going to be between 0 and 1. So if it's between 0 and 1, is that a contraction or an expansion? You got it, Kelly. It's going to be a contraction. It's going to get smaller. That's our math word of saying smaller is contraction. Okay? And so we can at least figure that part out. Okay, so if you kind of forgot, so far you didn't forget, we haven't even gone over it yet, what the center of dilation part means. Let's just take a look at the smaller part. We could at least get our choices narrowed down, right? So the image is smaller than triangle JKL. Yeah, that sounds okay. So A could work. B wouldn't work. D wouldn't work, though, because they're saying larger, right? So we could at least narrow our choices down. So it's either A or C. So 50-50. Sounds pretty good. All right, now let's read the rest of these. So it says triangle JKL is going to be on the same side of point C. Okay, or the opposite side of point C. So that's what this center of dilation at point C, that's where that part comes in. That has to do with whether the scale factor is positive or negative. So if the scale factor is positive, it's going to be on the same side of the center of dilation. If the scale factor is negative, it's going to be on the opposite side. Now, those are a little bit vague. So what I mean by same side is in between. So here's point C, our center of dilation, and here's our original image, triangle JKL. If the scale factor is 2/3, our image is going to be, what I mean by same side is it's going to be between the center of dilation and the image. So it's going to be somewhere in here would be where our new triangle ends up. It's going to be a smaller version, but it's going to be in between point C and this triangle. If the scale factor is negative, what happens is it's going to be over here somewhere. That's what opposite side means. It's going to be not between the center point and the original image. Okay, so now what do you guys think? Is it going to be on the same side of point C or the opposite side of point C? Because our scale factor is 2/3. So that has to do with whether it's a positive number or a negative number. 2/3 is positive, right? So do you guys see now that it would be answer choice A? Good. Yep, it's going to be a contraction on the same side. Very good. So how are you guys feeling about that? It takes a little practice, but once you once you practice it, it's okay. There's just kind of have to look at the categories and make sure you don't get confused, because there's a lot of, it's kind of tedious, so it's easy to get confused. But just be real careful and double check your work. Okay, good. I'm hearing mostly okays. I don't hear anybody saying they're not okay, but if you're not okay, that's all right too. Just got to tell me. All right, we're going to move on to 3.02 now, and this is question 1 and 5 off of your quiz for 3.02. So this won't be till Wednesday. So remember this for Wednesday, or you can come back and watch the recording again. All right, it says under a dilation, the point 618 is moved to 3.9. What is the scale factor of the dilation? Any ideas here? Just in like your intuition, is it saying maybe what you could possibly do here? So maybe we could sketch this out just really briefly. We have a point at 618. So let's say this is like 618 up here. I didn't draw this tick mark, so I'm not quite sure. But 3.9 would be like there, approximately. Okay. Okay, good. So, oh, sorry about that. Put it back on follow. There we go. Okay, good. Callie says it's likely 0.2. I think I see what you're saying, Callie. Not 0.2. Yeah, there you go. There you go. 0.5 is what you meant. Yeah. That, your intuition is correct there, Callie. That is correct. So you're going to use fractions to help you guys out with these type of questions. So what you want to do is take your original value, and in this case it's a point value. It could be like a side length, but you want to take your original over your new, or the opposite. Now the key thing that will tell you is to think about what's going on. Is it an expansion or is it a contraction? So if you're wanting larger, you want to get the number that's going to make it bigger, or if it's smaller, you want to get the number that makes it smaller. Derek, I think that they use dilation to, as more like the general term to say contraction or expansion. And so in this case, they're not, you don't know for sure. You kind of just have to look at the problem and figure that part out, whether it's going to get bigger or smaller. But in other words, let's say, like, if remember how we named the point, let's just make up a name for the point. Let's say this is point A and this would be A prime. So in other words, we're starting here and going here. So because the numbers are getting smaller, we can say, okay, that would be a contraction. Okay? Yeah, hang on. We're still in the process of explaining that, Anthony. Sorry. So to figure out which number, so let's take a look at the actual numbers. I think that might help me explain this a little bit better to you guys. We have, let's just look at the x values. We have a 6 and a 3. So I could do 6 over 3, or I could do 3 over 6. That's what I mean by like new and original, or original and new, is you could take your first value over your new value, or your new value over your second to get your scale factor. But your intuition will tell you which one is correct. Because we know, okay, I'm starting at 6 and I'm ending up at 3. So which one of these, if I multiply, is going to get me to a smaller value? So 6 over 3 would give me 2, and 3 over 6 would give me a half, right, or 0.5. So yeah, we want this one. Okay, Derek. Well, hang on a moment. We'll see if we can get to those, but we can also do it in tutor time. Okay. So in other words, if you take your original x value, and you multiply by 0.5, you will get the x value that you want, which is 3. That's where you want to end up at. Okay? So that's the answer that you're going to go with, is 0.5. Yeah, you could kind of think of it like that, Kelly. Yeah, that might help you remember. Okay, so let's try this next one. Okay, it says study the red pre-image. So this is where you're starting, and the associated blue dilation image. Then select the scale factor used to create the dilation. So Derek, this goes back to your question about what does dilation mean. Dilation, it just means you're either going to contract or expand. It could be either one. In this case, you can see you're starting with a smaller red triangle, and the new triangle that's created is larger. So in this case, it would be an expansion. Okay. But it could mean contraction. It just depends. It's sort of more of a general term. It says, then select the scale factor used to create the dilation. Okay, so what you want to do on this triangle, be careful and look at the mapping. Like, what might help here is to label the points. Let's say we label this triangle ABC. Where would, can you guys, I'll give you whiteboard privilege, label B prime and C prime. Good, yep, I agree with that. B prime would be down at the bottom and C prime would be over there. Yep. Yeah, and A prime ended up in the same spot. That's right. Okay. So now let's take a look at our values at B. So B is at 2, 2, right? And B prime is at 2, negative 14. Okay, so the Y value changed. And then the C value, let's see, C is at negative 2, negative 2. And C prime looks like 14, negative 2. Oops, negative right there. Okay, so this one, these dilations, I think they do get tricky. But what do you guys think? Anything you're kind of seeing here to help you out with this problem? What do you think maybe on the positive and the negative part? Let's just focus on that first. Any ideas? This one's kind of hard to see, and I know that I'm kind of throwing this at you blindly because you haven't gone over it probably yet. But good, Kelly. How did you see that? Where are you seeing that the center point is at? Good, Kelly. Yes, that's actually correct. Now, that's not always going to be the case, but in this problem, point A didn't change, and so that does mean that point A is your center point. So maybe next time, let's see what that, let me check really fast on that Math Warehouse link I gave you guys. Maybe there's some pictures on there, because I think that helps too. Just to see what these different dilations look like. So they do give you some examples there on that link. Let me put it in the chat one more time in case you guys missed it. But I would check that link out too because it'll give you some more visual pictures of the dilation. Okay, and it even gets into transformations and dilations, which we might not even need to do. Oh, let's see. Oh, it does show you pictures. Okay, so you have to go down below, it says, to see the pictures. I'm just trying to figure out, sorry guys, I'm kind of talking to myself at the moment, but what I'm trying to do is figure out, just get some more pictures for you guys. Well, maybe what we'll do too on Wednesday is come back and touch on this if it's still confusing to you guys after you go through the lesson slides as far as just having more pictures to visualize this with. But I think, I know, Derek, you said on 3.01 you're not seeing the images, and I haven't checked that yet, but on 3.02 you should see images for all of the questions except for question 1. Question 1 is the one we just did, but that also could help you guys out. Okay? All right, so any thoughts on this one? Now this one's a little tricky, I think, or a little like not as intuitive. Let's look at the side lengths. I think that might help you guys on this one. So let's take a look at side AB. How long would that be? How long is that side? This here. Some of you guys have the right answer already. Tell us how you're getting your answer if you already got it. So let's check. I'm just trying to help some of you that aren't seeing it to look at this differently. So this side, okay, good, hence Kelly. Yes, so we definitely know that we want it to be larger than 1. Let's write some of this thinking down. Larger than 1 because it's expanding. Your blue triangle where you're ending is bigger than the red triangle. So we could cross off A and B because of that. Okay. We talked about that we want it to be negative because it's on the opposite side of our center. So in other words, the center point is at point A, and our image is on the other side of point A. Okay, so yeah, just from those two things, knowing those two things would help you get to answer choice D, which is correct. I think this one's a little harder to see why it's the number 3 though. And that's why, let's take a look at the side lengths. I think this might help you see where the 3 comes from. If we look at the side length of AB, and then we look at the side length of A prime, B prime, which would be this side here, how long is that side? What would this side length be? Yeah, it is 12. Yep, 12. Okay, so we have A prime, B prime, the side is 12, and AB, the side is 4. And so the 3 comes from 12 divided by 4. Yes, very good, Nathaniel. Yep, and then you can do that same thing with AC and A prime, C prime. Okay. So you can see that what I mean by tedious is there's like lots of sort of little pieces to kind of put together, but it's kind of helpful because even if you maybe forget or part of this is confusing, if a couple things make sense, you can most likely still get the right answer if you understand, you know, what does the negative mean and what does the scale factor mean, okay? You are not, Derek, not at all. But this is, I mean, we've just barely touched on this, so we can come back and review some more on Wednesday, and then also maybe what we'll do, Derek, since we have a few extra minutes, we're actually done with 3.02, and that's where you need to get by Wednesday. Wednesday we'll talk about 3.03 and 3.04, which will finish you guys out for the week. But since we do have a few extra minutes, Derek, let's take a look at those 3.01 quiz questions that you're having trouble with. Okay, so let's see. It was question 3 and 4. Is that right? Okay, let me take a look at those. Okay, let me grab this question and we will take a look. I'm going to cover up the answers so you guys can figure it out. Okay, so here's question 3, and this is on 3.01. What do you guys think? Where might the center of dilation for a given figure lie? So the question that we just talked about, this one here, the center of dilation was actually point A, which was on the triangle itself, right? And yeah, this is a fair question, Derek, because I haven't given you other examples, other pictures to show what other dilations might look like. But you can have dilations where the triangle, so I'll just kind of sketch some real quick. Let's go back to that page. So you might have, like the picture we just have, where the center of dilation is actually on the figure. Okay. There are cases, let's say you had a triangle, the center might be inside the figure, and let's see, your final image ended up, if you were contracting, it might end up looking something like that. You could also have a triangle, or any image, and the center of dilation could be outside of it, and the triangle might end up looking like, well, it wouldn't look like that. It would look like, could look like that. It could, oh, I just want to delete that line. It's going to want me to delete that whole thing. Okay, so those are some different possibilities. That's what I was trying to look at on that website, but I couldn't find it, so I'll just sketch it for you. So yes, all of the above is actually the right answer there. Okay. Oh, I see. Yeah, I can see why that threw you off. Yes, yeah, so all of the above was answer choice A. I can see why that could be confusing. Yes, this one too, because all of the above would only include those two. Oh, that's another. Yeah, that's a good point. That's a good point. I should do that send feedback button. Because, yeah, what they're actually implying on this question is all the other choices are possible. So they should say all other answers or something. Yeah, if it's answer choice D, then that makes sense. That's the one you'd go with, right? But I can see, Derek, how that would be confusing if it's A, B, or C. That's where that shows up. Yep, yep. Okay, well, good question. I'm glad we clarified. So yeah, on question 3, you want to choose all of the above, whether it's listed as A, B, C, or D. That's the one you want to go with. All right, so let's take a look at question 4. Yeah, that's what they should do, Nathaniel, but they don't give you that option. You can't switch it yourself. They just give that to you. So yeah, I think what happens is they randomize the answer choices, but on the all of the above type questions, that doesn't really make sense. Right, right. I don't know, Kelly, because I'm not sure on the details of how all that works, but yeah, you'd think they could do that. That way A, B, and C get mixed up, but not D. Right, Achiro. Exactly, exactly. Contraction. Oh, okay. Yes, you do. Oh, yeah, I forgot to hide the answers on this one. Yes, you do have it right. Contraction is correct. Why is it correct, though? You guys can answer this question based on what we've talked about so far in CC. How do you know this is a contraction if the scale factor is 1/4? Let's just review. Contraction is what sort of range? What sort of range of numbers? Expansion is what sort of range of numbers? Yeah, that's exactly right, Derek. Fraction is a great hint because contraction, yep, the numbers are going to be less than 1, or we should actually say between 0 and 1. So there definitely are lots of fractions that are included in there. Now, the one thing you have to be careful about, remember that question was the second question I gave you guys, where there was a fraction, but the fraction was 3/2. So don't always put a fraction, or don't always think that the fraction is the answer, because 3/2 is actually 1.5, and that wouldn't be a contraction because it's larger than 1. So an expansion is a number that's larger than 1. Okay? But yes, a contraction is any number between 0 and 1. One helpful thing if you're kind of confused is to change the fraction to a decimal, and that will help you narrow it down. Alrighty, guys. Any other questions that we have before I let you guys go? So let me know if things come up before Wednesday, and then we can maybe cover some of this stuff on Wednesday. It is